I am here to talk about an Android developer's guide to machine learning. We're going to be looking at ML Kit and TensorFlow with a little bit of Firebase because of ML Kit. So for those that don't know who I am, my name is Rebecca. You can find me on the internet pretty much everywhere with the @Rigaroo handle. So if you want to ask me any questions afterwards, if you don't catch me, you're welcome to tweet me or just Google that. You might find me. So what do I do on a day-to-day? So I'm an Android developer. I work at a company called Over. And we're busy producing an Android app for design, basically. So you can create like flyers, posters, that kind of thing on your phone. There's an iOS app that's already on the store, so we're currently building out the Android app. So I do Android full-time, so not a machine learning person by trade, but hopefully today we'll leave you with a little bit of excitement into doing some machine learning with Android. Okay, so I want to ask a question to the audience. Who would consider themselves a machine learning expert? One person, that's great. Cool, so you can come do my talk, yay. Okay, so if someone had to ask me this question, I would probably be like, no, that's not me. I'm not a machine learning expert. Please don't ask me any machine learning questions. So today, I'm going to be showing you how you can add machine learning into your Android apps with very little experience in machine learning or how it works or that kind of thing. So if you have very complicated machine learning questions, I'm very sorry, but I probably won't be able to answer them. I can try, but hopefully one day I'll be able to answer all the hard questions. Okay, so does somebody want to take a stab at what is machine learning? Anyone? There's a T-shirt up for grabs. AI? Okay. Sort of. Okay, so I'll give you, you can get a T-shirt, but I'll give you the Wikipedia definition, I guess. So basically, machine learning is an application of AI. So AI has many different, encompasses many different things. And basically, with machine learning, you are giving your algorithms a lot of data, and it is learning by itself, I guess is what they call it. And it eventually comes up with like solutions to data that you've given it. Okay, so it's only as smart as what you've given it, and it doesn't like get smarter overnight unless you are giving it more and more data to sort of learn and adjust and get itself to be better at predicting certain things. Okay, so you can imagine if you have a large set of data, it's very easy to predict what you're looking at if you've got a very large set of data. If you've only got two sets of data or two things, it's very hard to say what the third thing is that you're looking at. Okay, so has anyone heard of ML Kit before? Yeah, there's a few nods. That's great. Okay, and there's a few no's, which is also good. So today I'm going to be showing you what ML Kit is and how it works. But basically, ML Kit is a new set of APIs that was announced by the Firebase team at Google I/O this year. So it's basically a whole bunch of different things that you can do to add machine learning capabilities into your Android or iOS apps. So like I just mentioned, the code that I'm doing today, even though it is in Android, doesn't mean that it doesn't work on iOS. It's really, really similar to write the code on iOS as well. It's literally the same API definitions and how it works. So everything I do in Android, you can do on iOS as well. So keep that in mind. Like I mentioned, it's part of the Firebase suite of products. Everyone know what Firebase is? Yeah? We love Firebase, so do I. So Firebase is basically, for those that don't know, it's a mobile set of tools for like really accelerating your mobile development. So you can really quickly, easily get up and going with like a backend very quickly. So it made sort of sense that this machine learning part is now part of Firebase because it's adding more additional features to your Android apps. Okay, so what is ML Kit? What does it have? So there's a bunch of different things that are part of this SDK that you can do. So the first thing is you can do text recognition. So that's the first image over there. So you can basically take a photo of a menu, of a street sign, or something like that, and it'll tell you what exactly that says that it can pick up. The next thing that you can do is face detection. Okay, so not face recognition. There's a bit of a difference because it won't be able to tell you that the person you are looking at is Rebecca. It'll just be able to say, that is a person, that's their face, and this is their eyes, and that kind of thing. So it can do that with face detection. Another thing that it can do is barcode scanning. So you can scan QR codes, a whole different range of barcodes you can do with ML Kit. You can also do landmark detection. So that's the bottom one, where you can take a photo or upload a photo of something, and it'll tell you you're looking at the Eiffel Tower, or you are looking at the Taj Mahal, or whatever. It's got a whole bunch of different outputs for that kind of thing. So I mean, it's backed by the Google database of images, so whatever Google knows of, it will probably be able to pick up your photo of that. And then one of the other things that it has is image labeling. So I'm not going to go through this one too much, but basically if you take a photo, it's going to tell you exactly what is in that photo. So if it sees the sun, the cloud, the moon, whatever it sees, it'll tell you and give you like labels for that image. And then you can do anything with that if you want. Cool. So anyone heard of Google Play services? Okay, so this is a bit of a confusion, and I wanted to mention this because it was confusing for me at first. But basically, if you've done Android before with Google Play services and you've tried to pick up faces, you may have come across this class called Google GMS Vision Face APIs. So there's a face detector, there's an OCR, there's landmark, there's a whole bunch of stuff within this Google Play services. And it's effectively the same thing as what MLKit is now. But I would say that this one is like the old version, and they're probably moving forward with MLKit. So if you come across this and you're like, which one should I choose? Probably go with the MLKit route, because it seems like it's the way forward. And this one is the old way. OK. So essentially, it's kind of like a rebrand and put all these different products from Google and all that into an MLKit product from Firebase. So if you go to the website firebase.google.com and you just search for MLKit, you will find really, really good docs. So the Firebase website has some of the best docs that I've worked with before. And here you'll find exactly how to do everything for all the different APIs. So let's have a look at how we can do face detection with MLKit. So the one thing that I want to mention here is that face detection with MLKit works offline. So this is pretty cool because you don't have to rely on a server to tell you if there's a face in the photo or anything like that. You can just run it on the device without any internet connection. OK, so who likes Instagram filters? I'm probably going to be the only one. Yay, I've got 2 people. The last time I gave this talk, there was only 1 person. So it's generally the ladies, and I'm so glad. OK, so I really like Instagram filters, Snapchat filters, whatever, same thing. But basically, we're going to try implement one of these today with MLKit. So how does it work? So basically, you take a photo. Obviously, you need a photo for faces. And you run this Firebase MLKit detector through with this bitmap. And it'll give you some information back. So it'll give you information about the bounding boxes. So that is information about the different coordinates of a face. So the top right, bottom left, right, you'll get all that information. And then you can draw a rectangle across, or you can do whatever you want with it if you want. The next thing that you get with this API is you get landmarks. So this will tell you where exactly the eyes are on a face. It'll tell you the mouth as well. It'll tell you cheeks and the ears. So it's a whole bunch of landmark information for each face that it can pick up. And then that's all you really need, right? So you've got all the different coordinates on a bitmap. So all you need to do is take some images and place them on those coordinates, and you've got a Snapchat filter or Instagram filter. So let's have a look at how we can do it. OK, so this is an example from the website. You'll see like the bounding polygon and all that information on the website is what exactly you get. OK, so let's try make our little Snapchat filter. OK, so all this code that I've got here is on GitHub, and it'll be shared on the slides and that on the meetup group as well. So don't worry if you get too lost. You can always check out the code. But basically, what I've got set up is an app that allows you to choose an image. So it's got a little selector from the gallery. And once you've chosen an image, it passes that bitmap to my function. And my function that I'm going to write now is going to call Firebase, pass the bitmap to Firebase, and then get the information from Firebase about where the faces are. And then we're going to just add those images onto the eyes and the mouth and that kind of thing. OK, so the first thing that you'd need to do for adding this is you obviously need to add a dependency, like Kurt mentioned with motion layouts. You need to do the same with for Firebase ML Kit. So you can see here I've added the vision API. Let's just make that a bit bigger. So that one's added into my Gradle file as well. And then I've just got a main activity, or let's just look at the fragment. So I've got a fragment that has a click listener on a button, and we will, on button click of a face, we will call our face detector to do some detection work. Okay. So that's where we're going to write our piece of code. So I've got this method called doFaceAnnotation, and that takes in a bitmap. Okay, so this is the bitmap that the user's chosen from their phone. So the first thing that we need to do in order to set up for Firebase face detection is we need to create the Firebase options. Okay, so this is basically saying Firebase Vision Face Detector options.builder, and here's where you pass certain things like the mode type. So if you want it to be super accurate, you can get all the information, and all the landmarks if you want all of them, or whatever other option that you want. So once you've got your options, the next thing that you need to do is set up your bitmap. Okay, so this is a Firebase Vision image, and you need to basically just call this and pass your bitmap in that we've just gotten from the UI. And now we've got this Firebase Vision image. And then the next thing that we need to do is create the detector. So all we do for this is we say Firebase Vision, get the instance of it, and then get the vision detector, okay? And we pass it in the options that we've created further up, these options. And then the last thing that we need to do is actually call detect and try and pass in our bitmap that we've created and try and get the landmarks from that. So the next step is face run. So we call detector.detect an image with that bitmap that we've created, this Firebase Vision image. And then we add an on-success listener, and we can add a failure listener as well if we want to do something with that. So this is asynchronous, and it will return when it's finished processing. And at this point, we will get a whole bunch of Firebase Vision face objects out. Okay, so that's the result of the processing of the bitmap, and that contains all the bounding boxes, the landmarks, and all that information. So I've built what I call the Snapchatify bitmap processor. And basically all this is doing is taking in that bitmap, that initial bitmap that we have, and this list of Firebase Vision faces, okay? So if we have a look at this method that I've got, this is where it gets a bit hairy, but it's not really of your concern because it is not really highlighting Firebase Vision at the moment. But basically at this point, all I'm doing is creating the eye bitmaps. And then for each face that's in that list of faces from Firebase, I'm doing a couple of things like getting the angle, the rotation, the bounding box. And then I've got a method called draw the mouth. So that draws the mouth on the bitmap. And then I've got the same thing for the eye for the left and the right of the person that we've detected. So it will then go and draw an eye on top of that bitmap that we've just passed it. And once it's finished doing that, it will do it for every single face, and it will return that bitmap to the function that's listed. Okay, so don't worry too much about the canvas stuff. The main part is the actual processing and detecting in the image and then posting that value back. So we can now run this app, and hopefully it works. Okay, so I updated my phone to Android Pie. No, it's cool. So let's hope nothing's gone wrong since then. Come on. Okay, cool. So at this point, I'm going to ask if I can get like a volunteer to come smile for me, and I'll take a photo of you. There we go, big smile. Eh? Cool. Okay. Why doesn't it have the photo? Come on. Okay, cool. So that's just loaded up the photo. So I've got a little sample app that's got those 4 buttons. So if I press the Snapchat button, hopefully it picks up his face. It worked pretty well. So So you can see I've got my own Snapchat filter going. I'm totally going to become the next Snapchat. Oh, wait, that's Instagram stories, right? Awkward. OK. OK, so that's basically the Firebase face detector. So it's pretty cool. I mean, this is just a silly example, but you could do some really cool stuff with it. And it also, awesomely, that it works offline. OK, so let's get back to the slides. So here's an example of it working on multiple faces. So these are the organizers, the GDG Johannesburg organizers. I think it's quite a cool improvement to everyone's looks. OK, so that's face detection. Any questions so far? No? Cool. OK, so landmark detection is the next one that we're going to have a look at. So this is one of my favorite ones because I like to travel a lot. So I like it to see what it identifies and picks up in my pictures. So one example of what it would pick up is obviously the Eiffel Tower. It's my beautiful drawing skills. And here's an example from the website, so like the results that you would get. So you can get information like the geographic coordinates where it thinks you took the photo, the bounding polygon of what it identifies in the photo, and also the confidence score of what it, like, does it really think it is this thing or not? OK, so one thing to note with this, I don't know if I've got it mentioned in a slide later. No, I don't. OK, so landmark detection doesn't work offline. This is a paid service, so this is part of, it's basically Google Cloud. So if you've looked at any of the Google Cloud landmark detection APIs, it's this. It's just like a nice wrapper around that for you with the Firebase stuff. So it doesn't work offline, but it is still really, really cool. So let's have a look at how you would do landmark detection. OK. Cool, so we've got, in our same app, we've got the same function, but this one is called do landmark detection. We're taking in a bitmap. And it's going to be of no surprise to you that it is similar, like pretty much exact same code as the one that we've just written, but for landmarks. So the first thing that we want to do is set up the detector, or the options first. Sorry, let's do the options. Yeah. OK, so the options, in this case, we're doing it a bit differently because now we're using the Firebase Vision Cloud Detector options. And now we'll say, give it the latest model as the type that we want. And we also want to set the number of results that we want as the to come back from the web service. So this is doing a service call. And the more results you request, the more Google's going to charge you. So you probably want to keep this pretty low, at least while you're busy with it. So once you've got your options, you just build up your options, and then you build up your detector. So Firebase Vision.getInstance and get Vision Cloud Landmark Detector, just a bit different from the face detector. Pass in those options. The next thing that we need to do is create the bitmap, so the Firebase Vision image bitmap that we did the same step before. And then the last step that we want to do is we actually want to detect what landmark is in this image. So we would then call run. And this one looks a little bit more crazy, but that's only because I'm doing some more stuff. But basically, we call detector, detect an image. We pass in this bitmap that we've got, and we add it on success listener. And in this case, we're getting back, you can see here, a Firebase Vision Cloud landmark, and not the Firebase Vision Cloud faces. So it's a bit different in what you get in that result. And at this point, I'm just doing some really horrible code to like loop through all those landmarks and add that information into a little result string, and then you're going to see that on the screen. So I couldn't think of like a cool thing to do with landmarks, so it's just going to post what it gets from the server. And then if you want to do some failure code, so like, I don't know, just show the user that something's gone wrong, you can just add it on failure listener as well. OK, cool. So we can run this one now. Let's have a look at how it works. OK, so let's choose a photo. So I have a bunch. Just need to find them. OK, so I really like traveling, like I mentioned. So I was recently in Milan, and that's one of the like big landmarks there. So now we'll press the landmark button, and hopefully it picks up where exactly we are and what we're doing. Cool. That was pretty quick. I didn't have any progress indicator on there, but anyway. So yeah, so it's picked up that I'm at the Milan Cathedral. The confidence percent is 0.91%, which is pretty accurate. And oh, it's also picked up the shopping center that's next to it, which is pretty interesting. I guess it knows that it's right there. Yeah, but there's like a shopping center here that's pretty famous as well. So it picked that up as well in the image. And that is pretty much landmark detection. So really simple to use. Obviously not free because it goes to Google. But I think the first 1,000 requests that you do are free or something like that. But it's all that information is on the website, so you can check that out as well. OK, let's get back to it. Cool, so here's just some more examples of it running. So Statue of Liberty picked up, New York City. It's a city in Italy called Turin. And you can see like its confidence levels get a little bit worse if the picture's a bit pixelated or something like that. OK, cool. So the next one is image labeling. So this one works offline. I'm not going to go into how exactly you do it because, spoiler alert, it's all exactly the same. There's nothing magical about any of these APIs. They pretty much follow the same thing where pass in the bitmap, get the result, do something with it. So this, like I said, works offline, but it can also work online as well. So the difference between the two is that if you use the online model, you pay. OK, difference number one. But you also get more sort of descriptive results. OK, so if you take a photo, for instance, this is on the website, you'll see it says on the device, you'll get the result of like stadium. But when you're on the cloud, you might get something like a sports venue or maybe even more accurate than that. So you've just got to sort of weigh up the pros and cons of the two and whichever one you want to use. So I'm not going to show you the code for that one because it's the same stuff. The next one is barcode scanning. So this one also works offline, which is cool. So free to use, so you don't have to pay. This one is actually the one that I battled with a little bit. So it wasn't as accurate as I was kind of expecting, which is a bit sad, but maybe I was just doing something a bit wrong with it. But basically, it's set up for any kind of barcode, so QR codes, any kind that you find in the store or something like that. This is an example from the website. So it gives you the corners, like the rectangle of where it finds exactly a barcode on the image, which is really cool. And also the raw value of what that barcode is or displaying. OK, so here's some code, exactly what it's doing, but spoiler alert, it's exactly like the rest of them. So you basically build up your options. So we're saying we only want to detect the QR code in this case, no other types of barcodes. We can do all of them if we want. That's the one that I kind of found to work. So yeah, that's what I've done here. Next step, create the bitmap, get the vision barcode detector this time and not the landmark or face detector. And then do the same thing. So we call detect in image, add on success listener, do whatever we want with the result of the processing of that. Cool. And here's some examples of it working in that sample app where you've used a QR code or something like that. OK, OCR is one of the other ones. So this one works offline, which is also really cool. But it also can work online, but you pay. Same thing as the rest. But basically, this will allow you to pick up text on anything. So pick up words on a street, on a book, anything like that. And so this is the difference between on-device versus on the cloud. So if you're on the device, you don't get all the languages. You only get Latin characters, or sort of want to say languages, but you get only Latin characters. But if you go to the cloud, you'll get any kind of, it says a broad range of languages and special characters. So and there, yeah, free for the first 1,000 uses of this feature per month. So yeah, so there's the difference between the two. You can use whichever one you want, I guess. So spoiler alert, exactly the same as the other APIs. So create the vision detector, pass in the bitmap, call detector.detectInImage with that bitmap, add an on success listener, and do something cool with it, like put the box around it, or I don't know, translate it or send it to someone. The world is your oyster with that. And here's an example of it working. So I was pretty surprised because this was a photo, a really blurry photo that I took of a presentation at Google I/O. So you can see like it's really hard to read what exactly was on there. But it managed to pick it up pretty well. And this is the offline version, I think, if I remember correctly. So it's not even the one on the cloud. So the free version, yay. OK, so let's get into a little bit more interesting stuff. So we've had a look at all the different all the different MLKit stuff that you can do. So there's a large portion of things that are really simple now. You don't have to build up any models for yourself. You don't have to learn what a face looks like and write that all yourself and put it on a device. That's all done for you. Like, it's really, really simple to do that now. But what if you wanted to do something like a little bit more custom? So you wanted to know a different type of box that someone's looking at, or you wanted to pick up the different types of flowers that someone might be profiling or something like that. So with MLKit, you can't do that just with MLKit out the box. You have to build up a custom TensorFlow Lite model. So has anyone built up their own TensorFlow Lite model? The people at the back that attended this talk the first time. Cool. That's awesome, though. That means that they enjoyed it, which is cool. OK, so basically, I'm going to show you how you can do that. And we're going to be building a little chip detector. But can anyone tell me what TensorFlow is? Rough guess. Come on, at the back. Pretty much. OK, so TensorFlow is basically Google's open source library for machine learning. OK, so it can do a lot of stuff, but the API is very, very low level, and it's kind of hard to understand and code yourself. Like, you've got to do a whole bunch of courses in that. But basically, how it works is it works on a bunch of nodes and data. OK, so if you think about it in a simple form, and this is like an example of how you could use TensorFlow. You probably shouldn't use TensorFlow for this kind of sort of simple math, but here is an example of what TensorFlow does under the hood when it's doing all its kind of processing. So you can see I've got these operations that happen. So we've got like the round operator, the +1, the absolute value, the floor operator. And this could be anything, any kind of logic that you want to do. And then I put input data into this TensorFlow board. And once I put in data, so you can see I put like a 3.6 and a 4.6 into these nodes, it'll go and run all these different operations and then sort of give you a result at the end. Okay, so this is sort of like the building blocks of TensorFlow. And obviously, when you use TensorFlow for image detection, it's doing a lot more complex stuff than this sort of simplified version. But this is sort of the basics of how it gets to where it gets to. That's as much as I'm saying about TensorFlow. OK, so because I'm not very skilled in using TensorFlow and I don't have a large set of data, I'm going to retrain an existing model. So this is quite a common practice with machine learning, is to take a set of data that's already trained and give it a bit more data and retrain it to be more specific for that set of data that you're looking at. So in this example, we're going to use the MobileNet V1 database. And this is a broad range of images. So this is things like picking up if you've got a dog, a chair, very sort of broad analysis of what an image is. Okay? But what we want to do is we want to be more specific. So we want to say, this is a knick-knack packet, or this is a cheese-knacks packet. Yeah. So once you've done that, like, we can retrain this model, this very general model, into being a more specific one just for our domain and our purposes. OK, so how do we do that? Yeah, so I've already sort of chatted about what we're going to be building. So what if I could tell what kind of chips I was eating? So this is a very sort of silly example, but you could take this and apply it to something really much bigger and sort of much more effective in terms of, like, you could make something where a blind person can tell exactly what can of beans they're looking at, or what can they're holding in their hands. So it's a very simple example, so bear with me. It's kind of fun and playful, but just think of like what more you could build with this kind of thing. OK, so there's 6 steps that you need to follow, or that I've followed, in order to get to what I have today. And we'll go through each of these steps in detail. But the basic is that we want to gather some training data, we want to process it into some image folders, we want to retrain our model, and then we want to optimize this model for mobile devices, and then we want to put it in an app, right? OK, so how do we do this? So the first step is to gather our training data. So you can see I have, in order to do this, I have taken some videos of the different packets of chips that I'm going to be detecting. And this is pretty much enough for sort of my small set of data that I'm working with. So what I've done, because I've taken a video, it gives you, basically a video is just a whole bunch of images, right? So all we're going to do in the next step is we're going to take these videos and we're going to convert them into a whole bunch of images. So I use a tool called FFmpeg. And this you just run on the command line, you install it, run it on the command line, and you give it the video, and it gives you a set of images out for that video that you've got. So this is the command that I ran for every single video that I want to train on. And then I've got a whole folder of images. So at this point, I've got cheese knacks, cheese curls, flings, and knickknacks. Okay? And each of those folders has images of those certain types of chips. Okay, so now we actually need to take this old mobile, not old, but this mobile VNet 1 model, and we need to call a retrain script on this model, okay? And what we pass in is this retrained graph. Lost my cursor. No, I don't have one. So basically, the script that we're running is scripts.retrain, and we pass in, the South African chips folder of images that we want, and that just has that list of all the folders inside. And there's a whole bunch of different options on here, and there's a nice code lab online that you can go read exactly what each different option does and how to run through this all yourself. But basically, we're setting up to say this is the input chips. These are all the chips we want to train on. Run this training script, and then it'll give you this retrained graph out at the end of this step. So that's the graph that we're going to use in the next step. OK, so what we need to do is that graph is not optimized for mobile devices. So often it's pretty large, and it can have a little bit of extra detail that we might not need for our mobile devices. So this Toko Tool, T-O-C-O, is basically for TensorFlow optimizations for mobile. And this is where you would pass in this graph that you just had from the previous step, this retrained graph, and you would get out a TF Lite file. Okay, so this is the TF Lite file that you're going to use in the Android app that you want to work with. Okay, this step was a little bit more difficult than it seems. I had to get Bazel installed and run the whole TensorFlow thing. But there's a whole bunch of documentation online and exactly how to follow this step as well. So if you get stuck, feel free to mail me as well. I'll help. Okay, so like I mentioned, this is based on a code lab. So there is some really good code online, and basically all I did was I checked out this code using Git. I ran it locally on my device, and the one that is online is basically just, I think it's a flower detector. But at this point, you can find the image classifier class that's located in this Google Code Lab for you. And the only things that you need to change is the model path and the label path. Okay, so the model path is that TF Lite file that we've just created from the previous step. And that little model that you've got, you need to put into your assets folder in Android. And then change the label path as well to the labels for the cheese knacks, all that kind of thing. It'll generate that file for you as well, so you can put that in your assets folder as well. And then you just need to run the app. Okay, so this sample app, like I mentioned, was not developed by me, but it is an example online from the Code Lab. And at this point, I'm going to ask everyone who's on the Wi-Fi or who has data, if you want to go and try out this app, we've got some chips to give away. And let's see if this works. OK, so who's going to download it? Chips. Free chips. There's Wi-Fi, guys. There's free Wi-Fi as well. Chips? Chips. Anyone else? Yeah? Anyone else?
Which one is it?
It's the one that says knick-knack or not. Yeah. Anyone else? Yeah? You want chips? What's up?
Thanks. I'm just going to eat them.
You good? Anyone else? Chips? Not even free chips? OK. Are you also downloading it? No? OK, you got chips? OK. Anyone else? No? Oh, I'm giving away all my chips and I haven't even got ones to demo. Okay, so who's downloaded it? Who's broken it? Is the next question. Okay, anyone got it working? No? Okay, so there's a couple people loading. You look like you've crashed the app. He's like, looks at me like, I've broken this. Did you break it?
It's not working. It had some error. It's working.
Okay, cool. Cool. So some have got it working. Okay, so let's have a look at how it works just on the big screen. So like I mentioned, this example is from Google, so I just put the different model in. So you can see we've got some knickknacks here on stage, and it's pretty confident in that it found knickknacks. 97%, really sure about that. Some flings, let's have a look. Oh, it's not so confident about the flings. 99%, okay. Anyone have cheese snacks that I can quickly look? Just chuck them here quickly. You can have them back. It picks up cheese snacks pretty well, and we did the flings. I think that was it. Cheese curls, but it doesn't matter. Yeah, so that's pretty much the demo of showing exactly like training your own custom model. The catch is that now, because you've trained it on this very specific data, it's going to think everything is either one of those four things. So if you look at this app now and you try run it on your computer, it thinks my computer looks like flings, which is cool. But yeah, so that's like, I guess, one of the drawbacks with this kind of model of retraining is that now you've got sort of limited to a certain set of data that you've trained it with. Okay, cool. Let's get back to the presentation. Did you get your cheese snacks back? Yeah. Cool. So here's just a recording of it working. So there's the cheese snacks, cheese curls, and flings. So obviously you can give it more training data as well if you want. So if you want to do it in like a low light condition, it might work a little bit more accurate or something like that. But just remember, this model was trained off just 4 videos. So I think it's pretty accurate considering I didn't put like that much training into training this thing. Okay, moving on. So the question that might come up is, what if this model that we've trained changes? Okay, so if you've now trained up on your different chip packets, but you want to now identify different, I don't know, different flowers as well or something like that. So typically what you're going to have to do is you're going to have to ship an app update, which sucks. Okay, so we know people don't download app updates. So we just got to hope that at some point the people will go and download your new version of your app, but it's probably not going to happen for a long time. So the other option that you have is to host this new model that you've created on Firebase. So this will automatically make sure that the updates are downloaded onto the person's device if they have certain conditions met. Like you can set that they should have Wi-Fi on the device, or it should be charging or something like that, but you can set that up on Firebase. So how does this work? So this is just a small extract of how it works. There's a whole bunch of bigger code lab and all that online. But the gist of it is that you set up this cloud model source, and you get the name from the one that you've uploaded online, and you set some certain conditions on it. So you set that you want this model to update. You want certain conditions like you should be plugged into Wi-Fi or be charging, that kind of thing. Please make sure people have Wi-Fi for this. And then what you would do is just register this cloud model source, okay? And then it will make sure that it automatically downloads this new model and uses it when the user uses your app for the next time. Like I said, there's a whole bunch more online, but I'm not going into detail about that. Okay, so after I did all of this, there was this really awesome code lab that I found online, which is an MLKit Code Lab from Google. And this is the one that does the custom model as well. So it goes through the steps of training, I think, as well as does the upload on Firebase and getting that model from Firebase as well. So I think the gist of this session and what I wanted to get across is that you don't need to be an ML expert in order to add these cool ML features into your app. You can quite easily create something that picks up different objects or finds faces in a photo without having to know exactly all the math and all the complicated stuff behind that. So I encourage you to go and have a look at all those code labs. They're really, really cool and fun to play with. One example that somebody came to me after I'd done my talk was that he had actually implemented in their production app a way to detect the different type of hardware that they were selling. So they have different purchase flows or some different setup flows for the different hardware. And he just implemented one of these small ML models. And now users don't have to go and find and like pick up what kind of device it is. They can just like scan it with their phone, and you can run the sort of setup flow for that. So I thought that was pretty interesting. Definitely a better use case than the one that I've just shown you. But yeah, I hope you go and have some fun with ML and show me what you've made with it. So thank you.